Hi everyone, this is Professor Monty. Today I'm going to show you how to do a t-test hypothesis test. So let's go ahead and read the problem. We'll talk about why it's a t-test. It says the average on exam 2 is a 75. A sample of 20 exam number 3 scores had a mean of 77 and a standard deviation of 8. Assume the scores are normally distributed. At a 10% significance level, does the data provide sufficient evidence that there is a difference in the exam scores? Okay, so here's the idea. We know that the average on exam 2 was 75%. That's our population mean for exam 2. We are trying to see if exam 3 has a different mean than the 75. So we took a sample of 20 scores, and out of those 20 scores, it says we got a sample mean of 77 and a standard deviation of 8. Now, we're testing a mean, so it's either a z-test or a t-test. Remember, a z-test, we know the population standard deviation sigma. This problem specifically says a sample of 20 exam number 3 scores had a mean of 77 and a standard deviation of 8. Well, that's the sample size 20, sample mean 77, and sample standard deviation 8. So they're telling us here S is equal to 8, so we don't have sigma, so it's a t-test. And we'll say it's because we don't know sigma. Simple as that. If we know sigma, it's a z-test. If we don't know sigma, it's a t-test. That's what we base the whole idea on. Okay, now let's talk about this. It's a hypothesis test. We always have to start with the hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis always has the equals. That's what we're assuming to be true. And so if we don't have any further evidence, we have to assume that the exam 3 score is the same as the exam 2 score, which was 75. So the null hypothesis is that the mean, population mean of exam 3 is also 75. The alternative hypothesis is what we're trying to show. It's answering the question. The question says, is there evidence that there's a difference in the exam scores? Well, a difference would mean the population means not equal to 75. Might be more, might be less. We don't know. We're testing to see if it's different, either more or less. Okay, so there's our hypotheses. We know it's a t-test. We're going to just go straight into the test. So I'm going to show you on the calculator, TI-83 or TI-84, how to do the test on the calculator. All right, so here's our calculator. We're going to go into Stat, Tests, and we're doing a t-test. So we can arrow down to 2 and then hit Enter. We can just push the number 2. It'll select it for us. Notice at the top it says t-test. Now, we don't have the individual data points, we have the statistics. So what we're going to do here is we're going to click over to Stats, hit Enter again. Now it changes, it says what's mu sub 0? That's the mu from the null hypothesis. Well, the null hypothesis, we're assuming, unless we have better evidence, that the mean on exam 3 is 75, just like exam 2 was. X bar is our sample mean. Where our sample mean, we got a 77. Our standard deviation, they said, was 8. Notice it says S sub X, S from the sample standard deviation, not sigma. If that had said z-test up there, that'd say sigma, because the calculator knows we have to have sigma if we're doing a z-test. And then the sample size in this case was 20. Notice the problem said that the data is normally distributed. Well, the scores have to be normally distributed or we can't do a t-test. Okay, in this case, we're going to choose that mu is not equal to mu sub 0. This is for the alternative hypothesis. So we'll hit Enter there, it chooses it, and then we just go down to calculate, and we're going to get our answers. All right, so let me write these down. So the t-value to 2 decimal places is 1.12. Put it up here. And the p-value they give us is, if we go to 4 decimal places, it's 0.2775. All right, so we've got that. All right, let's go back and finish the problem up on the board. All right, let me erase that. Okay. So here we go. So the idea is we compare the p-value, which in this case was 0.2775. I'll in fact erase this because now it's in my way. We're going to compare that. We want to see if that's less than or equal to my significance level, which it says up here was 10%. So 0.10, which is alpha, my significance level. Now, remember, we're testing the p-value with the significance level. We've set a cutoff of 10% that we're going to say, hey, I'm going to believe mu might still be 75. This might just be sampling error that has me at 77 instead of 75, unless the chance of getting that 77 or something more extreme is so rare that I don't think the actual population mean could have been 75 to begin with. Our significance level is what we determine to be so rare. Well, that 10%, if it helps you to change this to percentages, go ahead. This is saying 27.75% less than or equal to 10%. Well, we know that's not true. So the 27, almost 28% isn't less than our 10% cutoff. So it's not rare enough that we think it's probably not sampling error. So since this is not less than, since our p-value is not less than alpha, we do not reject the null hypothesis. If you need more explanation on interpreting the p-value with the significance level, whether or not to reject the null hypothesis, look at the post I made on p-values. It's only about it's a couple minute post. Look at that. Hopefully that'll help explain it to you. Okay, since I didn't reject the null hypothesis, I come to my conclusion. I answer the question. The question says, is the evidence sufficient to show there's a difference in the exam scores? We say no. The data is not sufficient. To show a difference in the scores. And notice what we're not doing. We're not saying, let's get that down so you can see the bottom of the board. We're not saying that, oh yes, I think mu is equal to 75. Well, we got 77 as our sample mean, which wasn't 75. We're just saying, hey, that might have just been sampling error. My evidence isn't strong enough to disprove that the population mean on exam number 3 could be 77. Or rather, that the population mean on exam 3 could be 75. It still might be. In fact, there's a 27.75% chance it could be that far away from 75. Or further, the sample mean, and still have a population mean of 75. So that's why we didn't reject it. So anyway, that's how we come to our conclusion. Hopefully that helped you out. If you like this video, if it helped you out, go ahead and subscribe. Click on the bell to be notified of further videos if you're interested. If you have further ideas of specific tests or concepts that you want me to show you, just drop a note. I'll reply to that. Hopefully we'll get some things up there that you can use in class. All right, with that, I'm going to sign off. Do some practice. One way I suggest practicing, look at the problem. Hit pause on the video, see if you can work yourself through the problem. If you get stuck, advance the video, see where you're getting stuck, see what the answers is, see what you should do next. But once you do a few of these, you'll get it. It'll be a piece of cake. So remember, you can do this.